And now it's recording. Right, so what we're talking about here...
I can see you.
You can see me?
Yeah.
Okay, so what we're
I can't see your head.
My head? Is that better?
No.
What about now?
Yes.
Is that better?
Yes.
Okay, because what we're talking about doing is trying to work out how moisture problems happen in buildings. And the first thing we want to do is just to understand something very, very simple, which is when there's moisture in the air from, in a building I guess it would be from cooking, from people breathing, and from just the moisture in the environment, or from drying clothes. That would be a way that moisture gets in the air. So all this moisture is coming inside, and so we're going to turn this kettle on, and we're going to boil the kettle, and Bertie, my assistant, is going to go and get a cold surface. Right?
Should I get the mug?
Yeah, you get that. Right, so we're going to be very careful. Right, so this is a very cold surface. This is a cold surface because this is a jar that we've had in the fridge, in the freezer. So it's very cold. And we're going to use this kettle, which is something that us builders always like kettles, because we need to have a cup of tea to keep us going. So the kettle is going to throw moisture into the air as it starts to boil.
6 minutes.
And we will see normally when you boil a kettle, it doesn't leave streamy wet marks around on the cabinets around it. It just boils, and generally the moisture just goes into the air because there's enough the amount of moisture in the air is normally such that you can put a bit more in there. And the surfaces around are normally the same temperature as the room, so condensation doesn't form. But if you have a cold surface, and this is what I'm trying to understand and work out, because at some point between inside the house here and outside the house on this cold day, there is going to be a cold surface. And if the moisture and the vapour with the moisture in it is allowed to touch the cold surface, so here's the kettle starting to boil, and it's quite happily chucking moisture into the air, and that is just disappearing into the air. It's not forming as condensation on the cupboard or anything, but if I do this and I've got this cold surface, and little droplets of this moisture start forming. I don't know, can you see that in the camera, Bert?
Not really. Now
No.
I can, because I just lifted it up.
Yeah, oh, you have to lift it up. But you can see that the moisture from the kettle is condensing on this cold surface, and then it's turning back into water, and it's dripping off this thing at the moment onto this tray. So that's the first thing. The first thing is that moisture
4 minutes.
naturally goes into the air
4 minutes.
from all of the use inside the building, and at some point between inside and outside, so inside at the moment our thermostat says it's 21 degrees, and outside it's not that cold today, but it's probably about 10 degrees. So at some point between inside and outside there's going to be a cold surface, and what we're trying to experiment this half term is to work out how the moisture travels through different things, at what point it turns into water and condenses if it does, and what problem that might cause or not if it's worked out correctly. So that's part 1. Over.
It's already on 3 minutes still.
Okay, good. Shall we watch it?